Hello there and welcome to this tutorial. In this tutorial, we are going to perform linear regression with Microsoft Excel. This is going to be used to answer the question, to what extent do student performance in science depend on their performance in mathematics? This means that we want to find out whether a student who performs better in maths can also perform better in science, or whether science depends on student performance in maths. I have data here from a study that has coded the test score of students in science and the test score of students in mathematics. Let's start the regression. To use the regression tab, click on data and then go to data analysis. In the data analysis dialog, scroll through and look for regression. So select regression and then click OK. Now when you click OK, the regression dialog box gives us the input y range and the input x range. The input y range is the dependent variable. So in this case, our dependent variable is science, and the input x case is our independent variable. And in this case, the independent variable is mathematics. So we click in the input y range and select the scores for the science. And then we click in the input the input x range and select the score for the math. That is the independent variable. Then we have the output range. The output range is where we want our results to display. So let's click below this place so that our results will display here. Then we have residuals. We can plot residuals, standardized residual plot, normal PNP plot, and so forth. But let's just take one, the line fit plot. That is the scatter plot and the line of best fit. Then we click OK. You see that when we click OK, the regression analysis result is displayed here. Let us briefly go through some of these results. For example, in the analysis, we found that the multiple regression coefficient is 0.39 and the R-square, which is the coefficient of determination, is 0.15. In other words, the R-square is 15%. This means that mathematics contribute to 15% of the variance in the student performance in science, or 50% of the performance in science is accounted by mathematics. Then we have the ANOVA. The ANOVA displays whether the regression coefficient is significant or not, and the value of the significant level is 0.02, which is less than 0.05. This means that the regression coefficient is significant. And also we have the coefficients for the various variables in the regression, and we can use this to write an equation that will predict science performance based on maths. So let's write the equation. So the equation is going to be y, which is science, is equal to the coefficient is 0.7. So we get 0.780x. Remember, the x is math, so we type here mathematics. Then the constant or the intercept is minus 0.685. This equation means that if we know the performance of a student in mathematics, we can predict his performance in science. So for example, if a student have 20 over 20, we can use this equation to see his performance in science. Or if a student score 1 in mathematics, we can use this equation to find how he will perform in science. This output represents the residuals, which is the difference between the predicted value and then the actual value. So we have the residuals here. Then we also, this is the residual. So we can see that the difference between the predicted value for the science and the actual value is not that big. So therefore, we can say that mathematics contribute to 15% of student performance in science. That is the extent to which science depends on that is the extent to which student performance in science depend on their performance in mathematics. Thank you for listening.